The National Electrical Code sets forth specific guidelines regarding the placement of electrical devices in proximity to bathtubs and shower enclosures. These regulations are in place to mitigate the risk of electrical shock due to water exposure. The primary requirement is maintaining a minimum distance of 3 feet between electrical devices like switches and receptacles and the perimeter of a tub or shower enclosure. This 3-foot zone is implemented to reduce the likelihood of water splashing onto electrical components, which could lead to dangerous situations. Additionally, the NEC mandates the use of ground fault circuit interrupter, or GFCI, protection for receptacles installed within 6 feet of the inside edge of a tub or shower. The GFCI is a critical safety mechanism designed to detect ground faults, which occur when electricity deviates from its intended path and flows through an unintended conductor, such as a person. Upon detecting a ground fault, the GFCI rapidly interrupts the circuit, cutting off the power supply and minimizing the risk of electrical shock. Ground fault circuit interrupters are designed to trip quickly, typically within milliseconds upon detecting a ground fault. This rapid response time is crucial in preventing serious injury or death from electrical shock. The installation of GFCI protection is especially important in wet or damp locations where the risk of electrical shock is elevated. Bathrooms, kitchens, and outdoor areas are common locations where GFCI protection is required by the NEC. These requirements help to ensure the safety of individuals using electrical appliances and equipment in these environments. The specific references within the National Electrical Code pertaining to these requirements can be found in Article 210.8 and 406.4 done of the NEC 2017 edition. Article 210.8 details the requirements for GFCI protection in dwelling units, specifying the areas where GFCI protection is mandatory. Article 406.4 done addresses the installation of receptacles in damp or wet locations, outlining the requirements for weatherproof enclosures and GFCI protection. When planning the electrical layout of a bathroom, it is imperative to adhere to these code requirements to ensure the safety of occupants. Proper placement of electrical devices and the use of GFCI protection can significantly reduce the risk of electrical shock and create a safer environment. Electrical codes are continuously updated to incorporate new technologies and address emerging safety concerns. Staying informed about the latest revisions to the NEC is essential for electrical contractors, designers, and homeowners alike. Familiarizing oneself with the applicable codes and regulations ensures that electrical installations are performed safely and in compliance with industry standards. Ignoring the regulations can lead to dangerous situations, including electrical shocks, fires, and other hazards. It is always advisable to consult with a qualified electrical professional to ensure that electrical work is performed correctly and in accordance with the NEC. These professionals possess the knowledge and expertise to navigate the complexities of electrical codes and provide guidance on best practices for electrical safety. Furthermore, local jurisdictions may have additional requirements or amendments to the NEC. Checking with local building departments or electrical inspectors is crucial to ensure compliance with all applicable regulations. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents. By understanding the risks associated with electricity and following safe practices, we can create a safer environment for ourselves and others. Electrical safety begins with awareness, and education is key to preventing electrical injuries and fatalities. Understanding the basic principles of electricity, such as voltage, current, and resistance, can help individuals to recognize potential hazards and take appropriate precautions. Regular inspections of electrical systems and equipment can help to identify and address potential problems before they escalate into serious issues. Look for signs of damage, such as frayed wires, cracked outlets, and loose connections. If you notice any problems, contact a qualified electrician to perform repairs. Never attempt to repair electrical equipment yourself unless you are qualified to do so. Working with electricity can be dangerous, and it is always best to leave electrical work to the professionals. Avoid overloading electrical circuits, as this can lead to overheating and potentially cause a fire. Be mindful of the amount of power being drawn by appliances and equipment connected to a circuit. If you are unsure whether a circuit is overloaded, consult with an electrician. Use extension cords and power strips safely. Avoid using extension cords as permanent wiring and never daisy-chain power strips together. Ensure that extension cords are properly rated for the intended use and that they are not damaged or frayed. Keep electrical cords away from water and heat sources. Water is a conductor of electricity, and contact with water can create a shock hazard. Heat can damage electrical cords and insulation, increasing the risk of fire. Be aware of the location of overhead power lines and underground cables. Maintain a safe distance from overhead power lines when working outdoors, and call before you dig to avoid damaging underground cables. Teach children about electrical safety. Explain the dangers of electricity and teach them to never touch electrical outlets or appliances with wet hands. By following these simple tips, we can all contribute to creating a safer environment and preventing electrical accidents. Remember, electrical safety is everyone's responsibility. The importance of understanding GFCI protection cannot be overstated. GFCIs are designed to protect individuals from electrical shock by monitoring the flow of current in a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the power supply and preventing potentially fatal injuries. GFCIs are particularly important in areas where water is present, such as bathrooms, kitchens, and outdoor locations. The presence of water increases the risk of electrical shock, and GFCIs provide an added layer of protection in these environments. GFCIs are relatively inexpensive and easy to install, making them a cost-effective way to improve electrical safety. Many older homes do not have GFCI protection in bathrooms and kitchens, and upgrading these areas with GFCIs is a wise investment. When installing GFCIs, it is important to follow the manufacturer's instructions carefully. GFCIs should be tested regularly to ensure that they are functioning properly. A simple test can be performed by pressing the test button on the GFCI. If the GFCI trips, it is working correctly. If the GFCI does not trip, it should be replaced immediately. In addition to GFCI protection, there are other measures that can be taken to improve electrical safety in bathrooms. One important step is to ensure that all electrical outlets are properly grounded. Grounding provides a path for electricity to flow safely back to the source in the event of a fault. Ungrounded outlets can pose a shock hazard, especially in wet environments. Another important consideration is the placement of electrical outlets and switches. As mentioned earlier, the NEC requires that electrical devices be placed at least 3 feet away from the edge of a tub or shower enclosure. This requirement helps to prevent water from splashing onto electrical devices and causing an electrical shock. It is also important to avoid overloading electrical circuits in bathrooms. Bathrooms often have multiple high-power appliances, such as hair dryers, curling irons, and electric heaters. Overloading a circuit can cause the circuit breaker to trip, and it can also create a fire hazard. If you are unsure whether a circuit is overloaded, consult with an electrician. Finally, it is important to be aware of the potential dangers of using electronic devices near water. Never use electronic devices, such as cell phones, laptops, or tablets, while in the bathtub or shower. If an electronic device falls into the water, it can create a shock hazard. Even if the device is turned off, it can still conduct electricity. By following these simple precautions, we can all help to prevent electrical accidents in bathrooms. Electrical safety is a shared responsibility, and it is important to be aware of the risks and take steps to protect ourselves and others. The National Electrical Code serves as a comprehensive guide for safe electrical installations. Adhering to its guidelines is crucial for ensuring the safety of buildings and their occupants. The NEC is updated regularly to reflect advancements in technology and address emerging safety concerns. It is important for electrical contractors, designers, and homeowners to stay informed about the latest revisions to the NEC. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides specific requirements for different types of electrical installations, such as residential, commercial, and industrial. The NEC is not a law, but it is widely adopted by state and local governments as the basis for their electrical codes. In many jurisdictions, electrical work must be performed in accordance with the NEC in order to pass inspection. The NEC is developed by the National Fire Protection Association, or NFPA, a non-profit organization that develops codes and standards to reduce the risk of fire and other hazards. The NFPA brings together experts from various fields to develop the NEC, including electrical engineers, contractors, inspectors, and manufacturers. The NEC is a consensus-based standard, meaning that it is developed through a process of open meetings and public input. This ensures that the NEC reflects the collective knowledge and experience of the electrical industry. The NEC is organized into chapters, articles, and sections. Each section covers a specific topic related to electrical safety. The NEC also includes numerous tables and figures that provide additional information and guidance. The NEC is a complex document and it can be challenging to navigate. However, there are resources available to help individuals understand and apply the NEC. The NFPA offers training courses and publications on the NEC. There are also many online resources available, such as websites, forums, and blogs. Consulting with a qualified electrical professional is always a good idea when working with electricity. Electricians have the knowledge and experience to ensure that electrical work is performed safely and in accordance with the NEC. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include state and local building codes, as well as industry standards developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. It is important to be aware of all applicable codes and standards when planning and performing electrical work. Compliance with these codes and standards is essential for ensuring the safety and reliability of electrical systems. Electrical safety is a critical concern, and it is important to take steps to protect ourselves and others from electrical hazards. By understanding the risks associated with electricity and following safe practices, we can create a safer environment for everyone. Always remember that electricity is a powerful force and should be treated with respect.